All right, so if you're running apps on Azure Kubernetes Service, or AKS, you're going to hit this huge question sooner or later. Where does all your data actually live? Well, today, we are going to architect the answer. Let's get right into it.
So you've done it. You've containerized your app, it's humming along beautifully on Kubernetes, scaling up and down like a dream. But when a pod just disappears, and trust me, it will, what happens to its data? That right there is the fundamental challenge of state in what's supposed to be a stateless world. And it's exactly what we're here to solve today.
Look, instead of just talking theory, let's get our hands dirty. We're actually going to architect a stateful application on AKS, one piece at a time. By digging into its different data needs, you'll see exactly how to pick the right Azure storage solution for each specific job.
Okay, but before we can even think about picking our Azure services, we gotta speak the language, right? Kubernetes has its own core concepts, its own way of talking about storage, and these concepts are the bridge between our application and the actual physical storage underneath it all.
First up, we've got the persistent volume, or PV. The easiest way to think about this is like a big pool of available storage resources. Someone, an admin, has already set this stuff up and made it available to the cluster. It's the underlying disk or the file share just sitting there, waiting to be claimed. So if the PV is the resource, how does our app actually get it? Well, it uses a persistent volume claim, or PVC. And this is the truly brilliant part. Your application doesn't need to know anything about the storage underneath. It just submits a little request, the PVC, that says, hey, I need 10 gigabytes of fast storage, and Kubernetes just figures out the rest.
All right, with those basics down, let's get back to our application. The first and maybe most important component is its database. This is the heart of our service, and you know what? It's got some very specific needs.
Databases, they're pretty demanding, right? They need two things, super low latency and crazy high IOPS. That's input-output operations per second. Basically, how fast it can read and write. Now, the crucial thing to know is that this kind of high-performance block storage can only be attached to one machine, or in our world, one Kubernetes node at a time. And that makes it a perfect fit for Azure disks.
And what you're seeing here is a perfect example of what we call dynamic provisioning. It's awesome. Our database pod just asks for storage with a PVC. The cluster sees that claim and uses something called a storage class. Think of it like a recipe to tell Azure exactly what kind of storage to spin up. In this case, a premium high-performance disk. Azure creates it, attaches it to the right node, and boom, the pod mounts it. It's a completely seamless, automated flow.
Okay, problem one is solved. Our database is happy on its super-fast, dedicated disk. But our application has other data needs. What happens when multiple parts of our app need to get to the same data at the same time? Now that's a totally different ballgame.
Just picture it. You've got multiple copies, replicas, of your web front-end pod. They all need to read from the exact same set of configuration files, or maybe they all need to write logs to one central directory. Azure disks just won't work here, remember? They can only be attached to one node. We need something that can be mounted by many pods at once.
And that is exactly where Azure Files shines. It's a fully managed file share up in the cloud that speaks standard network protocols like SMB and NFS. What this means for us is that we can create one single persistent volume that points to that share, and then have dozens of our pods all mount that same volume at the same time. It is the perfect solution for these one-to-many data patterns.
So we've got block storage for our database and file storage for all our shared stuff. But our application has one more major data challenge, and honestly, this one requires a completely different way of thinking. Yeah, let that sink in for a second. Not all data belongs on a file system. This is such a crucial mental shift. For years, so many of us have just thought about storage as disks and folders that we mount into our apps. But for certain kinds of data, that model just completely breaks down at scale.
I mean, think about it. Your users are uploading just massive amounts of stuff. Images, videos, documents, maybe terabytes and terabytes of it. Are you really going to try and stick all that on a traditional mounted file system? No way. It would be a performance and management nightmare. This is unstructured data. We call them objects, and they need a home that was built for that kind of massive scale.
So here is the big idea. Instead of mounting a volume, forget mounting, our application code is going to use an Azure SDK to talk directly to Azure Blob Storage. It's not accessing a file path, it's accessing data over an API. This totally decouples the storage from the pod's lifecycle and gives us, for all practical purposes, limitless scale for all that user-generated content.
Okay. Whew. We've tackled 3 very different data problems with 3 different Azure solutions. So let's pull this all together into a simple framework that you can actually use for your own applications.
Remember what we had? We had a database that needed its own private, fast storage. Then we had shared files that everybody needed to see at once, and finally all those massive user uploads that needed a totally different, scalable approach. 3 unique problems, 3 perfect tools for the job.
Okay, this slide right here, this is your cheat sheet. Let's really break it down. Look at that first row, Azure Disks. See the access mode? It says Read Write Once, or RWO. That's the key. It means only one pod can use it at a time. Perfect for databases. Now check out the next row, Azure Files. Its access mode is Read Write Many, or RWX. That's your go-to for shared content that lots of pods need to get to. And finally, look at Blob Storage. The access mode is different because it's not about mounting. You access it directly with an SDK, which is what makes it so amazing for those huge user uploads and media archives.
And of course, once you've picked your storage, you've got to make it ready for the real world, right? Production ready. And that means thinking about resilience. For both disks and files, you can and should use Azure's zone redundant storage options. That protects you if an entire data center fails. And obviously, you absolutely must have a rock-solid plan for backing up all this critical stateful data.
So, you've done the hard work. You've architected the perfect storage solution for your AKS application. You've matched the access patterns with the right Azure service. But that just opens up the next big question, doesn't it? Your storage is chosen, but how are you going to protect it, back it up, and prepare for disaster? Well, that's a topic for another day. Thanks for joining me.